Hello, everyone. I can see you all starting to come in. So welcome to everyone that's starting to join us. I'll give everyone a few minutes to kind of log in and join us on Zoom, but whilst that's happening, please do let us know who's out there. You can drop your name, and if you're associated to an organisation, in the chat channel, which is at the bottom of your screen. It'd be great to know who's with us. Great, just give everyone a couple minutes. Oh, everyone's starting to say hi now. Hi, Eleanor and Chris. Hi, Dave. Shropshire. Great. Oh, great. Lots of people saying hi in the chat. Okay, I'll get started with introductions whilst a few more people are coming in. But yeah, so good evening. Thank you for joining us. So I'm Tabitha Whiting. I'm the Marketing Communications Manager at the Low Carbon Hub, and I'm going to be tonight's host for this webinar. I think most of you will know this, but the Low Carbon Hub is a social enterprise that's out to prove that we can meet our energy needs in a way that's good for people and for the planet in Oxfordshire, where we're based, and beyond. So you join us partway through our series of webinars, which have all been focusing on the future of energy and the transition to a renewable energy system, particularly focusing on Project LEO. So for those of you who don't know, Project LEO, or Local Energy Oxfordshire, is a £40 million project conducting real-world energy system trials to better understand the role that local energy can play in accelerating the transition to a smarter and more flexible and, importantly, zero carbon energy system. So we've been running these webinars for a few weeks. Last week, we had a webinar with Dr. Sarah Darby of Oxford University's Environmental Change Institute, and she was talking about the involvement of people in smart local energy systems. And we had a great turnout for that one, but if you did miss it, you can find the webinar recording on our YouTube channel, along with recordings of all the webinars in this series. And on that, we'll also be recording tonight's webinar, which will be available online on our YouTube channel later in the week. Next week, we're welcoming Graham Oakes for a discussion on the role of flexibility in a net zero energy system. And you can find registration details for that webinar on our website. If you head to the news section, you'll find it. Great. So that's my introduction, all of the blurb at the beginning of this webinar, and I'll get onto tonight's webinar. So tonight our topic is unlocking Project LEO's electric vehicle flexibility. And I'm delighted to introduce you to our speaker, Paige Mullen. So Paige is the program manager for Nuvve's European vehicle-to-grid operations. Nuvve is the global leader in vehicle-to-grid technology, offering high-powered charging and grid services that optimize unused and renewable energy. And Paige specialises in the integration of electric vehicles, from grid connection to energy market qualification and participation. And she also works really closely on energy policy and regulation in London. And Paige has said that she's really happy to take questions during the talk and after the talk. So if you do have any questions as we go through this webinar, just pop them in the chat channel, which again, you'll find at the bottom of your Zoom screen. I'm sure you're all Zoom pros by this point. And we'll hope to answer as many as we can over the next hour or so. So that's it from me, and over to you, Paige.
Okay, thank you so much. Hi, everyone. As mentioned, my name is Paige Mullen from Nuvve. I work in our programs and operations for European projects, specifically working on Project LEO for Nuvve here in the UK. Okay, perfect. So tonight, kind of as mentioned, I'm happy to take questions throughout. So if you'd like to put something in the chat box, also pause throughout kind of as I'm moving into sections. So if you have anything, any questions, please feel free to let me know. We'll kind of go over who Nuvve is, sort of what markets we work in, a little bit about our company, what vehicle to grid is, and where the EV market's at right now, and how vehicle to grid is really helping enable more EVs to come onto the grid. We'll look at the benefits of V2G, a few different projects that we have around the world, so seeing how V2G is applied in different countries, in different markets, doing different services, and then finally bringing it back to Oxfordshire and how V2G is working in Project LEO. Nuvve is headquartered in San Diego, California. So although we started out in the US, we've been working on projects on 5 different continents. So what we do is when we look in these other continents, we'll look at what the market landscape is. So different services are paired to different markets. Not every market is the same. So we're really looking at how vehicle to grid can work in California with school buses, how it will work on local flexibility here in Oxfordshire, how we can do emergency power backup in Namibia, and really looking at different ways that vehicles can help support the transition to a smarter grid. We've been commercial now for almost 5 years, so 4 years. September will be 4 years in Denmark, providing frequency regulation. So it's the longest commercial operation of V2G in the world, and they're still driving every day. These customers need their cars, they need to go to work every day with them. And so it's really nice to see that as that's gone and we've continued to provide frequency regulation, that it really is a robust and long-standing operation and service. Here in the UK, we have a joint venture with EDF, who's one of our corporate investors, called Nuvve. Nuvve covers the UK, France, Italy, Belgium, and Germany. So kind of rolling out as a commercial offer through EDF. That's mentioned, yes, our joint venture. So we get kind of this question quite a lot is what exactly does Nuvve do? So we're not a hardware provider. We don't make or build any of the specific V2G hardware. We are a software company. So we look to optimize and aggregate all of the vehicles together. And then we'll bid that in as a resource. So then we'll kind of provide that service from these vehicles to different utility players, so whether that's a DSO such as SSEN or the transmission system operator such as National Grid here in the UK. We look at doing kind of multi-year contracts, so a service contract to our customers. So it's very simple for them. They'll tell us when they need to charge, when they need to have their vehicles ready, and how far they need to go. And we'll make sure that they have enough battery to do that, to be able to do that. And then on the other side, we'll lower either their energy bills or give back a V2G reward, depending on the different markets that they're in. And we specifically don't necessarily manufacture any hardware because we look to be hardware agnostic. Different countries will have different requirements. So therefore, we can work with a variety of different energy supply partners, but also with a variety of different hardware suppliers. One thing we've been seeing over the years is kind of understanding when this inflection point of EVs is going to come. But what we've seen is that pretty much every organization that's forecasting EVs has been adjusting their rates upwards. So bringing that inflection point sooner, which you can see on this BNEF chart here, that we're seeing that companies are being more aggressive in their forecast as customer adoption is growing. What we've seen, even in light of COVID, the last few months as vehicle sales have dropped dramatically, EVs are actually one of the only ones that still not showed as dramatic of a decline in that, and that customer perception of EVs has actually improved over COVID. As we've seen, appreciating cleaner air, quieter streets, those are all having people that maybe weren't considering EVs looking to go to EVs. So again, this charts as they're starting to update them again in BNEF's most recent 2020, they're moving this again sooner and sooner, which is a really great thing to see. But then we come into some issues of how are our networks going to be able to support this rapid transition? If whole neighborhoods and large volumes of people quickly are adopting EVs, how are we going to make sure we can all charge them? So then we come to look at kind of the network side and how are we going to be able to power all of these electric vehicles? So this curve here is from California. It's kind of affectionately called the duck curve, just due to its shape. And it's looking at the net generation. And what you can see is in the middle of the day, from around 2 to 3:30, 4 in the afternoon, the belly of the duck kind of sags down. And that's coming from a lot of solar generation. So excess solar coming onto the network and not as many people using as much power. Coming then to about 6, 7, 8, 9 at night, when everyone gets home from work, you're plugging in your car, it's going to be charging, you're going to be using TV, you're turning on lights and using a lot of power. So then you have needing to meet that ramp rate as you go up to the top. And this is one area where either you're going to have to dramatically kick in some other form of generation or storage that could come from batteries potentially, but you also could come from EVs. Electric vehicles, they've already been purchased by customers, and often they're parked during the day while potentially you're at work. And that they could be a resource to help kind of smooth out this so we can run at the most optimal curve on the electricity network. We're starting to see this in the UK as well, although this is an example from California. It's not unique to California. And the last few months, we've seen the UK grid running completely off of coal. We're bringing on a lot more renewables, and we want to make sure that we can use as much of that renewable generation as possible and help power our cars. So we're not going to charge them at periods when there is coal or there is more natural gas. We really want to power these as cleanly as possible. So as we're seeing, more passenger cars are becoming electric. And this is a huge amount of power that's coming on. Between 5 to 18 gigawatts of additional peak demand is coming onto our networks right at that evening peak, coming from unmanaged EV charging. And this is huge amount of money that's going to cost the network operators and then down to us as the consumers if that's not managed appropriately and in the most optimal way. So what we want to look at is how we can shift that bit of red unmanaged EV load into something more controllable. That's where we look at smart charging. So smart charging is one way where maybe we just time when we charge these vehicles. And that's great, and it does do some help into shifting that peak period. But with bi-directional charging, so vehicle to grid where you can actually discharge, what we can see is we can have further benefit by actually lowering that evening peak even more and discharging at that peak. And that's really going to put a lot more energy back onto the network to smooth out those curves at that peak periods of the day. Do you have any?
We've had one comment asking about kind of the possibility of charging EVs up at work just whilst you're on that kind of charging side of things. Is that an option?
Yes, definitely. So I think that's a great one to be looking at, is where you want to charge and how your kind of business model is going to go. I think workplace charging is a great time where you want to be charging up during the day to capitalize on that solar energy. Right now in the UK, we can look at essentially the pricing, so day ahead wholesale energy pricing, to essentially forecast that. And there are some carbon index curves for the GB grid as a whole. There's not quite a direct market yet for that. But that's something that would be interesting as that does start to come, is, are there signals and is there a value associated with that? It's great in theory just to say, yes, we'd like to charge on that, but if that's going to cost more, are customers willing to do that? But daytime charging, typically, if there's a lot of sun, you will get a lot, you'll be charging primarily on some of these renewables, especially if it's a nice sunny day out. So this kind of, it's great in theory looking at the benefits of V2G, and we can talk on curves and look at this, but it's really, what are the benefits in the end, and to the final consumer, to society, and to the network. So we see it reduces the cost of electrification, so we can lower the prices for the network operators, and that value can be passed down to the customer. So that person who owns that vehicle, whether that's a business or an individual customer. It helps defer investment in grid upgrade costs. Right now, one of the big costs for fleets looking to electrify is that network reinforcement cost they may be required to pay, and helping look at how they can optimize that behind their meter. So maybe charging and discharging just based off of their own energy use on that building, so they don't need to upgrade their supply capacities. We're looking at lowering CO2 and pollution from vehicles, taking more gas and petrol cars off the road, and again, charging at workplaces where you can really charge up on that solar energy, and helping balance out, so providing a frequency regulation to help balance out the intermittencies that we get with renewables, such as times when the sun's not shining and the wind's not blowing, really how we can help support those in bringing on more renewable energy onto the grid. So in order to realize these benefits, we typically target 3 kind of key markets, looking at the transmission system, the distribution system, and behind the meter. And it's really for V2G in order to make the most benefit out of it. It's stacking each of these services. So it's not just looking at one of these services in a silo, but it's really how you can play across all of those. With vehicles, you are very location specific. If you're looking down to the distribution level behind the meter, there's a lot just to look at on that specific level. So each site is very different and needs to be taken into account for that and understanding what the local constraints are. So this is what we're looking at in Project Leo, is looking at this distribution system and how do we help build out these markets for that to help bring that value to the customer at the end, but also provide a service to the DNO so SSEN can minimize some of their investments that they need to do and defer those later and help the network run as optimally as possible. So Nuvve's platform takes second-by-second control of matching power generation, transmission system, distribution, and the end consumer, and looking at for each of these sites, what are the best markets to play in, and how do we access each of those? As I mentioned, every site's going to have slightly different constraints, but when we're providing a service, a constraint management service to the DNO, they're just gonna want to know that they have a consistent and reliable service coming from this aggregation of vehicles. So sometimes those might all be located at the same site, and sometimes they may be a few sites on the same substation level. And that's what Nuvve's role is, to essentially smooth out the intermittencies and the unpredictable nature you get with EVs and provide a predictable, dispatchable, and reliable service to the different system operators that we work with. So it takes each individual vehicle, although one car on the network might not be that interesting. When we're starting to look at volumes of hundreds and thousands, we're looking at megawatt sizes of vehicles that are all going to be plugging in at the same time without that visibility. So by going through aggregators that look at that and take into account the driver's needs, as well as the grid's needs, that's where we can provide the best service and extract the most value. So looking at it in V2G, so bi-directional, so charging and discharging, but it's also important to look at just smart charging. Smart charging is just as similar as kind of mentioned before, just the delay in charging, which is still very valuable. And there's different use cases for doing both of these, but the value that you can generate is typically much, much higher, 8 to 15 times higher with vehicle to grid, since you can charge and discharge. So you have a greater service window you're able to provide from that. Right now, there are a lot of limits for V2G in the vehicle availability, although that's changing. Right now, commercially available in the UK, we're looking at your Nissans and your Mitsubishis for commercially available vehicle to grid vehicle vans and cars. But you can do smart charging with any electric vehicle. And again, it's not looking at one vehicle, but how do we look at vehicles as a whole, where you can balance cars that can charge and discharge and cars that can just delay their charge, and how do you marry those together to provide a holistic service to a fleet? Again, these are real customers. So here's a photo montage, I guess, of a few of the different customers we have around the world. So from the bottom right, you can see that's Frederiksberg in Denmark. That's the first commercial vehicle to grid fleet. We've got Nuvve, which is a London-based site here. We've got some customers in France, in Japan, in Namibia. And each of these customers and sites, we're looking at different services and different optimizations for this. So wanting to look at what are the value propositions we can give for school buses and school districts in the US, as well as for municipal vans that drive around every day, fixing things in their communities. But the most important part is that these are real customers. They have to get to work in the morning. They need to do their job. And so they need to make sure that their bus or their van is charged up to where they need in the morning. So that's really what we want to make sure works for the customers, is a simple method where they plug in, they just set a few parameters, and then we'll optimize the rest, and they get that value. So they're rewarded for lending their vehicle to help participate in the energy system. So looking at a few different situations that we have and a few different kind of examples around the world. One of these here is Frederiksberg Forshining in Denmark. So this is the first kind of commercial fleet since September 2016. Every day we've been bidding into the markets for frequency regulation. Each vehicle is generating around 1,800 euros per year per van on the frequency regulation market. And then these are passed through as values to the end customers. We've recently kind of re-upped our contract and are installing 4 more chargers. So we've got 2 more already installed at their site. So adding more as they've got more vehicles to help look at how much more we can save and optimize for their fleet here in Denmark. Another example that's really picking up and is on a different spin is in the US is with school buses. Dominion Energy, in a very unique case, has specified that they would like 1,000 vehicles or of their school buses to be V2G capable, and they're going to bounce them off of ratepayers as grid assets. So they're really looking at these school buses that if they can do vehicle to grid, it's enough that they can justify as an investment from their utility to get regulatory coverage to rate base some of these school buses, which is a really wonderful thing to help provide school districts, primarily looking at lower income school districts and those with poor air quality, of where they can bring in electric school buses for those students in that community, but then use these school buses in vehicle to grid mode for Dominion Energy to help balance off their network and use them as very large batteries. Another example is in Bornholm, which is an island off of Denmark. This is somewhat similar to Project Leo in the form of looking at local energy and how we can optimize at a very local level. So at certain points of the year, this island will be disconnected. It's technically connected by an AC cable to Sweden. And at that point, it has to function completely on its own local island. And here we've got, we're rolling out around 100 to 150 vehicle to grid chargers onto that station, onto that island to help balance out the intermittencies in their renewables. Denmark in general has a lot of wind, so their frequency is deviates quite a lot. So it's a very lucrative and important service to be providing. So these vehicles will drive all over the island, but also providing services to balance out their network. In California, we're also looking at distribution deferral. So when there's upgrades needed onto these networks, particularly looking at a microgrid with a large solar array in California, the University of San Diego, California site, we'll get a signal from a transformer monitoring system that will tell us what's happening on that system, so we can help make sure that with these vehicles, we stay within safe, controlled limits. This is looking at, instead of upgrading that network, how we can modernize and use smart, intelligent controls to minimize that upgrade needed and defer that to a later point in the year and allow to have more solar available. Perfect. Any questions before I move on to a little bit more about Project Leo?
Yeah, we've had a few questions come through, so maybe this is a good time. So a couple of questions about, I guess, kind of statistics and how it works. So question on what's the typical aggregation size? Are we talking about kind of megawatts?
Mm-hmm. Yeah, so right now for the chargers we use in Europe for kind of your normal fleets are each 10 kilowatts. So we're not quite at the full megawatt scale yet, which does pose some barriers in market access. So we do usually need partners for these market access, which is more of a regulation hurdle to overcome. But it doesn't necessarily technically bar us from participating in any of those. But then again, as you aggregate more vehicles, you'll have larger scale deployments of that. But yes, one charger is around 10 kilowatts. But in the US with some of the school buses, we're looking at 60 to 100 kilowatts. So those you get to a megawatt scale much faster if you look at bus depot sizes.
Yeah, great. And then we've had a question on decision making, I suppose. So does the driver decide when the car discharges to the grid, or is it all done by a smart system? And following on from that, is there then a danger that the car could discharge electricity to the grid at the wrong time, I guess? So they've suggested before the driver makes a long journey and needs a full battery.
Yeah, so that's where we have the customer will set their preferences. So they'll say, I need to leave tomorrow morning at 8 a.m. and I need to go, 100 miles. And they'll set that in the system so that that's taken into account into our aggregation. And then we'll make the decision based off of what are the most lucrative markets to be participating in from a revenue perspective to charge or discharge that battery. So as long as the customer just sets their departure time and kind of their desired state of charge, then we take that into account already. And you can set a standard. So it says every weekday, I need at least 85, 90% or 100% charge. And we'll make sure that's what's in your, how much state of charge is in your battery every morning.
Yeah, so mitigating for that kind of situation. Great. We've had a question which you may get quite often. So I guess it being headquartered in California, do you have any kind of relationship with Tesla as kind of a big volume of battery power?
Yes, so we've worked a bit with Tesla, but not primarily on a V2G side. If you look at Tesla, they've got a battery that they'd like to sell you as well from the Powerwall. And so we're kind of looking at more how you could just use the vehicle instead of buying extra assets from it. I think that's something they've looked at. Their first version of the Roadster was V2G capable, but no, we don't typically work with them in that. They kind of have their own little silos on that. But we do work with a variety of auto manufacturers, most of the major other ones from PSA, Nissan, Mitsubishi, Toyota, and then some of the big bus manufacturers in the US.
Thank you. Last question for now, one that just came in, which I think is quite an interesting one. Do you think that car clubs and vehicle sharing is something that would grow significantly? And if so, does vehicle to grid offer kind of advantages to that economics of car sharing?
Yeah, absolutely. I think that's a great question, because I think car clubs are a really great use case for vehicle to grid. I think it's one, particularly because car clubs are going to make their money off of when that car's checked out. And we'll look at how can you make the most of that asset when it's not being driven. And that's really the proposition of vehicle to grid. Is the number one use of this vehicle is to drive. You need to be able to do your daily driving, and we're always secondary to that. So we always prioritize the customer's driving needs first. But in that sense, that's where it works really well with car clubs. If we can look at a car club where you'll rent in the app and you'll schedule what time. So you usually say, I need to pick up this car at 5 p.m., which is perfect, because that's exactly what we'd want to know is you need that car at 5 p.m. So we can play around in the markets, but as long as we're ready for you at 5 p.m., that's perfect. So I think car clubs are a great use case for this in the booking systems. And I do think that the area they work best, particularly in the UK, is when they're tied to a building load, since that's where you get a lot of the value in the UK. So it's also just understanding kind of the business model of where they're located. But again, as we start looking at more local flexibility services, such as with DSO services in Leo, that's one where that business model may change a little bit, as hopefully we see a lot of value coming out of that in balancing that on a local level.
Great. And actually, one last question, since you kind of mentioned business models, and I think we've had a couple of questions around kind of the finances, whether this is short time scale for stabilization and could the market saturate, and then another one on kind of, are the financial benefits stable over time, or could there be rapid changes and loss of value when this new economies reach equilibrium? So similar kind of question there.
Balance out, yeah. Yeah, I think those are all very good questions in kind of what happens in the business model. What we're seeing right now is the business model, as the few years, that as we've been going, has been getting better as markets are becoming more open to aggregated assets and smaller assets. So we're actually seeing we're able to participate in more markets than we were a few years ago. So therefore, we have more revenue streams we can bring in, as well as cars are getting more, are coming down in price. So we're having more volumes of cars. More auto manufacturers are going into V2G, which is making that much cheaper, as well as the drop in hardware prices. That's definitely been a barrier the last few years, is rather large, more expensive hardware, but as that price comes down to relatively on par with your standard normal charger, V2G is going to be much more attractive, I think, in the future than we're looking at today. And again, a lot does depend on what energy markets you're in. The values are very different from the UK, even just to France, in what you can earn based off of their structures and their market requirements.
Great, thank you. I'll let you carry on with the presentation.
Okay. Wonderful. So now look, I've kind of touched a little bit on kind of vehicle to grid, a few different projects around the world and different markets that vehicle to grid can play into. So when we look in Project Leo and kind of where specifically Nuvve and vehicle to grid fits in, some of you may be familiar with this slide. I know it's a little busy, but what we'll look at is kind of down in the technology platform. So in this bottom right quadrant here, you'll see Nuvve and the aggregation. So this is really where we're aggregating and optimizing the EVs that are in kind of the bottom center left quadrant here. So we'll be aggregating those vehicles on a kilowatt scale basis, which is quite unique to be able to provide that visibility down to a kilowatt level charger on the network to let a DNO know, here's how many chargers are connected at this level, and here's our dispatchable and reliable resource we can provide you on this node at the end of your network. So we'll be aggregating those up. So we'll be connecting these vehicles. We're looking at installing in a few community sites that we're in the process of installing, as well as on some partners, some Leo project partner sites for putting these vehicle chargers so that we could be able to use them both as EVs, but also look at sites that maybe have solar on the roof as well, or a very large building load, and how we can bundle all of those together, or look at just the EV. And then from there, we'll bid that through Piclo's platform into SSEN's DSO flexibility tender to provide that service to them from dispatching these vehicles. So here's a photo from the Royal Borough of Greenwich. So this is also in London, so unfortunately not in Oxford yet, but where we've got 5 of the vehicle to grid chargers that we're operating. Again, these are going every day. Looking at on this site, I'm trying to optimize off of the carbon intensity in the UK. So how can we charge these with as much renewables as possible? And then also looking at how we can offset peak consumption during the day for this. In Project Leo, we'll look at doing kind of potentially some of those similar services, but also looking at how we can enable kind of different business vehicles and fleets, since that's our primary target is fleets, to participate in local flexibility and help lower their total ownership costs for owning and operating EVs. That helps get more people interested in purchasing EVs if we can help make that cost lower, either on their electricity bill or through other V2G rewards that we can pass back through to them. And then looking at how we can stack services. As I mentioned at the beginning, we don't want to look at just one service in its own as a silo, but really it's stacking of multiple different value streams and services onto that to make it as lucrative as possible for that customer while taking into account the customer's driving needs. Which we'll also be participating with these vehicles that we're installing in Oxfordshire in the minimum viable system trials. So looking at kind of small rapid test of essentially small prototype testing of these different services and different components of the whole system as we go about. So some of these looking at how we bid into it through Piclo, how they're notified, what happens if the vehicle's not available for some reason, how that process works are some of the things that we'll be looking at, as well as an aggregation across multiple sites. So if we've got 4 locations on the same substation, how can we aggregate all of those together to provide that service to SSEN? And then as I mentioned, we'll be installing these on a few community sites that we're working on, as well as our partners' locations, to help give as much visibility into these vehicles and make sure we can use them in an everyday situation. So we know that they'll be driven and used in a real regular driving pattern to make sure we meet their drivers' needs, but also can really look at what else is happening on that site to get the most value out of these MVSs. Finally, we're contributing to some of the DSO market requirements. So helping develop what are the kind of proposals for rules and regulations for how do we actually have this market going forward. And one of the big considerations is in a lot of more traditional markets that are already very well established, they have very high minimum bid windows and bid capacities, meaning we'd have to have 1,000 vehicles or hundreds of vehicles in order to meet their minimum thresholds. And we're really looking at this future system of a more flexible and integrated system. We're going to see solar on roofs more often. We're going to see batteries, we're going to see EVs. And these are much smaller than your traditional large power plant size generation. And so we really want to look at making sure that the new DSO market requirements don't accidentally inhibit any of these, but really help foster more local and smaller participation into these networks, but still be able to provide reliable services to the DSOs, so we can help make sure that our networks function safely and efficiently as possible. Thank you. Any other questions? Anyone? I don't know. Tabitha, if there's any more in the chat box.
We've got one just coming in. Are there types of market actors with whom you could imagine partnering, but it might be difficult at the moment?
So I think it would depend on the different markets. So not necessarily looking just at the UK, but in other areas. So for instance, in the UK, in order to provide FFR, you have for frequency regulation, you'll have to have quite a high minimum bid. So what we can do through that is through partnerships, we'll bid in through essentially a market access or a larger participant that can bundle us into their larger portfolio. So therefore we're still able to participate, but then we don't have to meet some of the same capacity requirements, such as a 1 month bid tender, where obviously vehicles are going to come and go on an hourly basis. We'd want to look more granular on that. So we could look at a lot of different market participants for that. And again, it'll just depend on what kind of service we're looking to provide.
Yeah, great. Got a few more questions. So one about the actual kind of V2G software. Does it sit solely in the vehicle, or could that be managed from an EV charger or kind of a DNO smart meter?
Yeah, that's a great question. So there's, we want to look at two different sides of the chargers. There's the DC side, so where the AC to DC conversion that will happen in the charging station. Those are typically larger chargers. But some of the newer vehicles that are coming out are going to be AC, which means that that's going to happen on the vehicle. So that inverter is going to be native to the vehicle. Those charging stations are going to be smaller. In that case, the V2G signal would happen with the vehicle versus sometimes it could happen with the charger. So right now, most commercial deployments in Europe are done with through the charger. And that's because of the CHAdeMO communication, which is the standard that Nissan uses, allows for V2G in a standard format. And so that's just where that's at right now. But we're seeing that pretty much all auto manufacturers are now shifting more towards the AC version and looking more at CCS, these other standards to do that, which brings more of the onus onto the car manufacturer. So it'll be done internally, but it'll make the charging station much smaller and somewhat easier to install. There are some questions around the inverters that the DNOs, I'm sure, are quite interested in how that's tracked. So it can be from both sides of that. Right now, it's not done through the DNO's smart metering system, but there is a lot of information that would be very useful to start connecting into that from the smart meter systems.
Yeah, and I guess kind of on that home charger aspect, we've had a comment around someone who has an EV and charges at night in their home and is kind of asking about, I guess, kind of scaling up, and saying kind of an issue with that approach would be that every vehicle would need to be plugged in when it's not being used. So you'd have a big increase in charger numbers. And do you see that as an issue, or kind of ways to overcome that scalability question?
I don't think there's an issue in having more chargers. I think the issue is when everyone charges at the same time, I think is more the important question. So with vehicle to grid, we pretty much say anytime you're not driving and you're parked, just plug your car in. That's not going to have kind of added amounts going onto the network versus unmanaged charging, where if everyone comes home and charges right at 6 o'clock, that's where we're going to have an issue, as well as some of these default time of use concepts where it says, okay, well, all EV chargers can't charge at 6, but they'll all start charging at midnight. We'll kind of create other peaks, versus if we can look at this more from an aggregation and more of a holistic approach, we'll be able to integrate those and not create artificial peaks later from that.
Yeah, brilliant. What else? We've got quite a few questions now. So a question about this kind of rapid discharge and recharge effect, and what that would do to the battery life and whether it would significantly reduce it.
Yeah, so we're approved by Nissan to do vehicle to grid, and it is approved by their standard protocols. So we're always operating within the battery manufacturers and the OEMs approved limits. And again, if you're looking at this, 10 kilowatts in and out is not that much compared to the amount of energy that you'll do if you're accelerating out of an intersection. That's a lot more power dramatically going right into the battery, pulling out of that, than you'd have doing vehicle to grid. But that definitely is something that we take very seriously and monitor all of the batteries that we're working on right now. And in the cars that we've been doing vehicle to grid for almost 4 years now. In Denmark, we check that every month. We check the battery state of health, and we haven't seen any added degradation due to vehicle to grid. The biggest impact is driver behavior and calendar aging.
Mm-hmm. Well, that's useful to know. What's the kind of average battery life, just for reference?
The average battery life, I believe the manufacturers, so car manufacturers, will cover 8 years, I believe, on that.
Okay, great. And then we've had a question about kind of longer term storage. So do you think you would ever get into longer term storage, like a calm, dull November scenario for kind of storage needs?
I'm not familiar with the calm, dull November scenario. We can elaborate on that?
Who was it?
Or is it like secondary life of batteries?
When there's no sun and no wind.
Yeah, I think as long as there's markets, like there'll still be a frequency regulation market, there'll still be wholesale optimization, there'll still be time of use. So there are still plenty of services that can be provided that are not tied directly to the weather scenarios.
Great, thank you. Question from Simon, so on Leo. So is one of the questions that Project Leo is trying to answer whether the potential cost savings to the DNO could make facilitating E to G financially attractive, and do you have evidence that this could be likely to be positive?
I think from a Project Leo, kind of as mentioned, that is the big question, is what's the value of DSO services in the UK? We see V2G as financially viable today in other markets, such as in the US, in Denmark, in the UK as well. We're just not sure yet on DSO services. So I think that's one that's the big question we're looking to answer, is what's the real value for this? But we do see a lot of evidence that it is going to be positive. In the UK, the values that we're seeing coming out of UKPN's tender, and with Piclo in theirs most recently, I think it was £14 million for that. You know, the values are looking very good from our side. We're adding a lot more kind of weight of DSO services into our business model. But the hard thing is that is very location dependent currently. So we have a few customers in the UK, but unfortunately none of them are in constrained zones, so we can't participate in any of those markets. So that is something that does need to still be weighed, is until we start having a lot more DSO competitions, it will be very location dependent on whether that's something we can offer those customers.
Thanks. And then a question on the kind of infrastructure. So could a vehicle to grid vehicle connect into chargers on various parts of the grid, or would it just be a specific kind of identified one for that vehicle?
Yeah, no, they can, if you have a Nissan Leaf that's doing vehicle to grid, you can plug in anywhere you can find a type 2 or, you know, the connectors that you need. So you absolutely can connect anywhere on that. It's just to actually perform the vehicle to grid service, so the discharge service would need to be at a vehicle to grid compatible charger. But you could still use the rapids on the highway corridors.
Yeah, and I think the last question I can see that we haven't answered for now, on kind of Nuvve and what you do, I guess, and do you also look at kind of batteries in the home?
Yes, we don't work so much with currently direct batteries in the home, but we do work with second life batteries. So we did a trial in 2009 and 2010 with the electric minis. So done with kind of BMW in the US. And those cars provided vehicle to grid in 2009, 2010. And now we have them when they were kind of done with their original useful life in the EV. They've been pulled out and now we're using them as stationary storage as kind of separate batteries. For that to, again, provide the same services we were providing 10 years ago with them, but now they're just a stationary battery. So conceptually, you know, a battery on wheels and a battery in your home are, you know, we can do that in the same way. There's just a more dynamic element that needs to be taken into account and a lot more constraints with batteries on wheels. So with vehicles, since that can drive away, we need to make sure it's ready to drive away when you need it to. But yes, yeah, we could do the same thing with home batteries, but specialize in the kind of highly dynamic elements of vehicles.
Yeah, great. And one question that I've missed, so sorry about that. What do you think on the power quality issues of EV chargers, such as harmonics and unbalances, while you have several EV chargers running in a zone?
I think on that level of a technical question, I need to defer to somebody else on that. So.
Yeah, that's fine. We'll try and answer that question for you after the webinar. I think that's all of the questions I can see. If anyone hasn't had your question answered, just copy and paste it back in. But I think we've covered them all. Oh, one coming in from Marcus. Could being part of a V2G scheme help users with better monitoring of their batteries?
Yes, absolutely. That's there's actually a study out of Warwick University that looked at kind of battery health in EVs, and that's something that we're kind of, you know, continuing to explore and have seen some cases where we think that by operating just within the kind of safe deemed limit, so never hitting that very top level and never hitting the very bottom levels of these EV batteries, by kind of just operating within the safest limits, that it actually could prolong the life of them. Again, that's still too early to necessarily tell fully on that, but that's absolutely something that we're looking at as a potential, another potential benefit of vehicle to grid.
Great, and another one that I missed. So looking at the case of Denmark, since it's the oldest project, what's the typical communication delay requirement? For instance, vehicles need to discharge within X seconds.
So in Denmark, it's, I believe it's about 90 seconds, I believe, in Denmark. So it is not as fast as it is in the UK. The UK is 2 seconds. So you do need to have a much more kind of innate or ingrained kind of frequency meter response times for that. In Denmark, I believe that's the time. And then in the Netherlands, we had somewhere around, I think it was about 45 seconds or so, I believe, on that one for it. But a lot of that is kind of improving those are kind of some of these more high frequency, high response time markets. You know, as we're getting kind of newer hardware that is developing, those are markets that are easier to reach.
Great, thank you. Yeah, I think that's all of them then. Yes, I think so. Just check the Q&A.
If anyone has any follow-up questions, feel free to send me an email. I'm happy to discuss as well.
Yeah, you can see Paige's email on the screen, and we'll also send up a kind of a follow-up email, so you can always get in touch with us as well. Okay, I think that's covered it for now, but yeah, do send in any other extra questions. So yeah, we'll start wrapping things up then. So thank you so much, Paige, for joining us tonight for what's been a really informative webinar and taking lots of questions from everyone. And thank you to everyone who joined us as well as attendees and for your great questions. So as we mentioned earlier, we do have another webinar this time next Tuesday, which is looking at flexibility in a net zero energy system with Graham Oakes. And we hope to see lots of you there as well. But that's it for tonight. So thanks again and enjoy the rest of your evening. And thanks again, Paige, for joining us.
Thank you, everyone. Thanks, Tabitha.